All right, so far you've gone through a few transformations. The first one we went through was a vertical translation. The second was a horizontal translation. Then we went through some vertical and horizontal reflections. And the last lesson we went through was a vertical stretch. So we're going to go through the very last type of transformation we're going to look at, and that is what we call a horizontal stretch. Okay, so in a horizontal stretch, we are going to introduce a whole new variable. But before we do that, I want to go back to what we already know. Okay, so far we've learned this function, y minus k is equal to a times f of x minus h. Okay, so there are a few transformations that we applied so far. Remember, our k value had to do with our vertical translation, so moving it up or down. Our h value had to do with our horizontal translation, so that was moving it left or right. And then finally, the last type of transformation we looked at was this a value, and that caused what we called a vertical stretch. So moving that or changing the shape of the graph to make it look narrow or wider. Okay, so the next type of transformation is the horizontal stretch. So with the new transformation, we're going to introduce a whole new variable, and that is going to be variable b. Okay, so where is that b value going to go? Well, the key word here is horizontal. Now it's only going to affect our horizontal values. So in other words, our x values. Okay. So our y minus k is going to stay the same because remember that had to do with our y's, okay? Also, our a values are not going to change because that had to do with our vertical stretches. But what it will affect is what is inside our brackets here. Remember, this caused a horizontal translation. So with this x value, we have also a vertical stretch. And that vertical stretch is going to be represented by our b value. It's going to come right outside of our x minus h expression, and then we're going to close it with a square bracket. So there is the function that you guys are all going to be getting to know very well. This involves all types of transformations that we learned so far. But in this lesson, I want to go through what this b value does to your function. Okay, so moving on here, let's look at this slide here. So the graph of y is equal to f of b times x involves a horizontal stretch. Okay, so that b value affects only the x values. So for the sake of this lesson, the only thing we're really going to be looking at is what are happening to our x values as we transform our graphs, okay? So the first case we're going to look at is when our b value is greater than 0, okay? So we have a graph on the right-hand side there, and we're going to transform it to a function by a horizontal stretch, okay? So here's our original function, y is equal to the absolute value of x. And since we want to apply a horizontal stretch, we need to pick a value of b that is greater than 0. So I'll pick b is equal to 2. So therefore, my transform function is going to look like this. Y is equal to, remember, it affects what's inside the function. Okay, so 2 times x. It's inside the function. So let's see what happens to this graph. Now I already set up this graph. Let me just get it loaded up here. Okay, so there is the graph of y is equal to the absolute value of 2x. And remember, we only are concerned about what happens to my x values from the original graph to the transform graph. So let's pick a point on the original graph. I'll pick that one right there, 6, 6. Okay, and we want to know if we leave our y values constant, because that's not what we're looking at, if we leave those y values constant, where does it go on the transform graph? So we'll leave our y values constant. So I'll draw a horizontal line so we know it's constant. And we want to know if I trace along that line, where do I end up on the transform graph? Well, let's go ahead and trace. Well, along the line, if I stay on it anyways, I'm transformed to that point right there. Now, what is that point? Well, it's going to be 3, 6. Remember, our y values stayed the same, which is good. But what changed are our x values. So we went from 6 to 3. So we halved our x coordinate. Let's pick another point to see this behavior. Let's pick 4, 4. Okay, so let's see. If we keep our y coordinate constant, what happened to the x coordinate? Okay, so let's keep our y's coordinate. We'll keep it at 4. And now let's trace along that line. Where did it go? Well, 4 traveled from here to here on the original graph, okay? All right, so what is that point? That point is 2, 4. So remember, our y values stayed the same, which is good. What we're concerned is what happened to the x values. Well, look at the x values. We went from 4 to 2, okay? So we halved our x coordinates. So let's write that there. X values are halved, okay? Notice what our b value was. Our b value was 2, and our x coordinates were halved. Okay, let's take a look at the second scenario when b is greater than 0 but less than 1. Okay, so we have the original graph, y is equal to the absolute value of x, and we're going to transform it to a function where your b value is greater than 0 and less than 1. Now I'm going to pick 1/2. So our transform function is going to look like this. Y is equal to 1/2 of x. Okay, so let's see what this graph looks like. Now I already prepared this graph. I'll just get it loaded up here. Right there. Okay, so my graph got a little wider than our last transformation, which is fine. But remember, we're only concerned with the only thing we're concerned with are x coordinates. Where did they go from the original function? So let's pick a point here. I'll pick the same point. Oh no, I'll pick this point right here, 4, 4. I want to check where, if we leave our y coordinate constant, where did it go on the transform function? So remember, keep the y coordinate constant. So let's check. Where did it go here? Well, it went from 4, 4 to 8, 4. Okay, notice what happened to the x coordinates this time. We went from a 4 to 8, so we doubled our x coordinate under that transformation. Let's take a look at another coordinate. So I'll pick that point right there, so 3, 3. If we leave our y value constant, so if you leave 3 constant right there, what happens to the x value? Well, it goes right over here on our transform function, and that point is 6, 3. Okay, so y values stay the same, which is good. But what happened to the x coordinates when we applied a stretch factor or horizontal stretch? Well, my x values became halved, okay, or not half, they doubled, sorry. X values doubled. And once again, what was our b value again? Our b value was 1/2. So this is what makes this really interesting. Is that from here, our first example, my b value was 2, but my x values were halved, okay? And our second example, our b value was 1/2, but what happened to the x coordinates? Well, they doubled, okay? So what can we conclude about the transform function, horizontally transform function? Well, here it is. Y is equal to f of b times x, okay? So how do we find the stretch factor? Well, in all our other examples, it was the reciprocal of whatever the b value was. So since our b value up here, our b value was equal to 2, our stretch factor was equal to 1/2. So all my x coordinates were all multiplied by 1/2. Okay, let's go back to this one. My b value was 1/2. So therefore, my stretch factor was the reciprocal of 1/2, which is 2. So all my x values doubled. Okay, so this is what makes the b value so tricky. My stretch factor is not just b, but my stretch factor is going to be 1/b. Okay, so this makes things a little bit more interesting. So what happens to a point? Okay, say we have a point xy on the original function. When we apply a horizontal stretch, what happens to that point? Well, our y values stay the same, they stay constant, but what happens to this x value? Well, we're multiplying by whatever our stretch factor is, and our stretch factor is the reciprocal of our b value. So x times 1/b is going to give me a new coordinate of x/b. Okay, so x becomes x/b under a horizontal stretch. So there is my introduction to what a horizontal stretch is.